All right, well, welcome to Teaching AP Computer Science Principles, Professional Development. What we're going to do is take a look at the Beauty and Joy of Computing, or the BGC Curriculum, and kind of tell you what this course really is all about. So why do you want to teach AP Computer Science Principles? There's actually a lot of good reasons why you might want to do it, and honestly, as long as you teach AP Computer Science Principles, any reason will do. But here are some that are pretty common. So the first one is workforce preparation. Now, what are we talking about there? There's a lot of jobs in computing. So we have this chart here that shows you that about 16, 17% of jobs are actually related to computing. That doesn't mean they're just doing computing. That also includes things like you're working for an engineering company, but what you're doing is coding for the engineering company. So it's really important piece of the pie. Another reason that I think is very important is because you're introducing a discipline, okay? If you ask little kids, what do you want to be when you grow up? They'll say fireman, they'll say doctor, they'll say nurse. Not a single one of them is going to say computer scientist, right? And that's okay, because who do they know to? Well, they know firemen, they know policemen, they know doctors, they know nurses, they know teachers. Those are the jobs they know about, okay? Now, little kid grows up, goes through high school, learns about math, learns about science, learns about all sorts of things. They come to college and they start looking at those as potential majors. They don't even consider computer science a lot of times unless they have some direct experience with computers. A lot of that in today's world comes from gaming, okay? But we want to try to broaden that. We talk about broadening participation in computers, and that means that we maybe want to attract more women to computer science, maybe we want to attract more minorities to computer science, and some stats, like from code.org, tell us that young women who learn about computer science in high school are 10 times more likely to pick that up at the university, right? Maybe they won't be computer science majors, but maybe they'll actually teach or learn a lot about computers in whatever discipline they're using. So that's one good reason why we want to do that at the high school level, right? Now here's another reason, social justice. This is really a big deal for me. Computer science doesn't just have jobs out there, it has really high-paying jobs out there. So it's a career that you want to encourage students to pick up if you're thinking about things like lowering the inequality gap or something like that. But you know what doesn't work? What if the people who are already at the top of the economic chain do computers because they have them at home and so on, and the people who aren't at the top of the economic chains don't take computer science in high school, they don't take it in college, then all you're doing is making that gap bigger and bigger. So just from a social justice perspective, we have to teach computer science at the high schools, and we got to get students in those classes, okay? Now here's another reason, which honestly, I wasn't that big on, but my colleague Lean has convinced me that this is true, and that is that it's a path to math. Because sometimes students will take, I don't know, maybe pre-algebra in middle school, they take algebra 1 in high school, geometry, algebra 2, and they start to lose ground, and it's like, oh, maybe we're not in a strong mathematics path. And so what we might do is, well, maybe we'll let them not take any more math, or maybe they take algebra 3, algebra 4, 5, 6, 7, where what we're trying to do is just let them see it again so that eventually it clicks. Why don't let them see something else, like computers? They learn that, they learn logical thinking, and all of a sudden they start seeing mathematics in a new context, and maybe they get back in the wagon, the mathematics wagon. So that's one of those things that's possible. We've seen it happen. It's not my top choice of a reason why you want to do computers, but it's actually pretty justifiable. Yeah, let's teach computer science so that some students can get back on the right track in math, okay? So all of these are good. Now, let's say I convince you and you're going to teach computer science principles. Here are some things you really should know about this course, okay? And if nothing else, I want you to be able to say these things when you talk to your principals and so on, and try to evangelize computer science principles. So number one is an introductory computer course, okay? So a lot of people will have the instinct, oh, first let's teach them, baby computing, right? And then we'll teach them toddler computing, and so on. And eventually we get to computer science principles, AP, advanced placement. No, don't do that, okay? First course, advanced placement, computer science principles. This has lots of benefits. Number one, hey, it's advanced placement. There's a little glory that goes with that, right? I took so many AP courses in high school. People like that, the parents like that, okay? It is a college level course. Otherwise it wouldn't be advanced placement. It really is a college level course. But guess what? In college, we don't assume that you know how to program when you come in to our introductory programming course. We can't assume that because a lot of high schools don't teach programming. Right? So this is an introductory programming course, okay? So don't feel like you have to teach 4 years worth of computing to get them to this. Just bring them in, we'll take care of them, okay? Second thing I want you to know, this was designed from the ground up to broaden participation in computing, okay? So here's what I'm talking about. Let's say you offer a computing course in your high school and a group of students says, oh, I love computers, I want to sign up for this class. And then later you find out that these are the kids who play a lot of computer games, okay? You might find that it's skewed predominantly male because gamers tend to skew predominantly male. And you find that you're enforcing the stereotypes about computing, not deliberately, but just kind of the way it happens. And then there's other kids looking at it going, oh yeah, those are the kids in computing. I'm not like them. I don't want to be a computing kid. That's actually hurting as opposed to helping. So this course was designed from the ground up to be inclusive, okay? How do you do that? Well, in a lot of different ways, but one of those is to be creative, right? One of the big ideas in this course is that computing is a creative task. And so you want to reinforce that. You want to show them that it actually takes creativity to be a computer scientist. And that's really the way you have to think. It's not trying to make the people think like computers. It's actually trying to get the computers to be useful to people, right? That's what computing is for. So that is just step one in this class, okay? We want to have the technical stuff, of course. You can't, this is not computer appreciation. You're actually going to learn how to program. You're going to build stuff with computers. But you're going to learn about the social impact as well, okay? That actually, again, brings in different people because some people can be more attuned to the technical stuff. Some people are more attuned to the way that computers affect them and their friends and so on. And so they will all kind of respond to this class at different times maybe, but they'll all be involved and they'll all be able to participate, okay? It has broad appeal. In some of the exercises, for example, from this particular curriculum, we're going to talk about things like geometry, okay? Okay, so the math people are going to be interested. But we're also going to talk about things like encryption, and we're going to talk about things like communication and then the government, and so now the social science students might be more interested, and so on, right? So that's the way that this is approached, right? Now, I want to bring you this metaphor. This is about Pixar, not the Matrix, okay? So here's what I mean. If you have money for posters in your classroom, and try to get some, okay? Put up posters of Pixar, right? Because when you put up a nice Pixar poster, say Coco, right? What you see is art, absolutely beautiful art, right? Great storytelling, great graphics, and so on. All of that is computer generated. And oh my God, you mean you use computers to be able to make hair that moves like that? That's amazing. That's not something that we show a lot, right? Instead, when we talk about computers, we show the matrix, right? And little letters come screening down and they're in a computer font and all that stuff. That is not as inclusive. That speaks to the people who already love computers and who already think that that's the way to do things, right? And maybe it doesn't help us bring in others that come from different backgrounds that might actually find that computers are cool, okay? Last, this uses pedagogic computer languages. So for example, AP Computer Science A is the other computer science AP course. They do Java, okay? Java first day, Java on the second day, Java on the third, it's Java throughout. It is all Java for a whole year. That's great if you happen to be the kind of kid who likes computers, right? There's nothing wrong with that. We love those kids. But it doesn't speak to the other kids, okay? So, they're understandably not going to want that class. And in fact, they might say, you know what, this whole computer thing, not for me, okay? In here, what we say is, look, we don't care what computer language you use, okay? There's a reason why computer scientists in college learn Java, because they're going to get jobs as computer scientists, and Java is one of the main languages for that, okay? But there's also a reason why, even if you are in the Air Force Academy, the first planes that you learn how to fly are not like an F-15, okay? You used to learn actually little turboprop planes, right? They now do jets, but still really simple jets to fly. And why is that? Because the point is to learn how to fly, not to be a fighter pilot yet, right? Likewise here, we're not worried about teaching you how to program for life. We're just worried about teaching you how to program, how to think like a programmer. Computational thinking, some people say, right? That's what we want you to get out of this course. Maybe you're done after that, maybe not, right? Maybe you'll pursue it, and then you can learn Java. So this, again, makes it more accessible to a lot of students that have perhaps not as strong computer backgrounds as others, okay? So let me emphasize that there's only one prerequisite for this class. It's Algebra 1, okay? A lot of students take that in middle school, which means that in 9th grade, they could be taking AP Computer Science Principles. It can't be done. I've actually had 9th grade students take this class and do well in it, Okay. All right, so let me tell you about this course in a nutshell. Okay. There are 7 big ideas: creativity, abstraction, data and information, algorithms, programming, the internet, global impact. Those are the 7 big ideas that the students will learn in this advanced placement course, right? There are 2 performance tasks. These performance tasks actually replace the free response questions, if you're familiar with those from the AP exam. Instead of free response questions, they have to do these 2 performance tasks before they actually take the AP exam. Those are the explore task and the create task. So let me tell you a little bit about each one of those. We'll go over them more in the rest of the course, of course. Okay, so big idea 1 is creativity. Here's the myth. Computing is a technical thing that's repetitive, and it's got semicolons and braces, and it's all about putting the semicolon in the right place. It's boring. The best analogy that I have for that is like finding x in an algebra class. That's all you have to do is, what's x? I don't care. Okay, well, that's how a lot of people see computing, right? By the way, they might see algebra like that too. They will later learn that stuff is useful, right? Because they might see finding x in the context of an engineering course where x has meaning, right? Computing is like that too. You can actually learn computing just by focusing on the semicolons and the braces. Between you and me, I think that's what AP Computer Science A does, which is why I prefer principles, okay? But it's actually a lot more than that, so let's treat it that way, okay? So really, what is computing? It's actually a creative task, right? Think of Pixar, right? It's focused on solving problems. This is something a lot of people don't understand, even my college students, right? They get so used to all the technical, the hard stuff of computers that they can't answer the question, why are we doing this, okay? And the answer, of course, is because somebody needs it. Somebody has a problem, and we're fixing that for them. We're building a solution for them. That's what computers is all about. You will find that many students love the technical stuff. Oh my God, you mean I can do this? This is amazing, right? And others will be like, who cares, okay? But then you tell them, hey, you know that I can actually get this going in a self-driving car? And they'll be like, really? And all of a sudden you start bringing them in and you draw them because maybe you speak to stuff that they care about, right? We can actually use this to help people. This will save so many lives in the highways, for example, right? All of a sudden, this has meaning, okay? It is actually a blend. I mean, real life computing is a blend of technical stuff. If you don't know the technical stuff, you can't do it. But I usually don't worry about that at first because I find that people can learn the technical stuff even if they're initially scared of it. Usually they're scared because something went wrong in the algebra class and they panicked, okay? But we can bring it back, all right? It's analytical, right? I want to solve this problem. I need to understand that problem, right? I need to see it from different perspectives so that I can find a solution that really works. That's analysis. And it's personal skills because people might say, I have this problem. By the way, sometimes they don't even say that. You just notice that they have a problem and you say, hey, how can I help you? Right? And you start trying to learn, and maybe they don't have the time to talk to you or tell you things in the way that you need to so you can understand them. Well, it takes time to kind of get that information so that you know what you need to do, and then you have the analytical skills to bring that down to the place that you can use your technical skills to actually solve it. That's what computing is, and that's really a creative process. Second thing about computing is abstraction. Okay? Abstraction is very important in computing. Honestly, I think it's like the #1 skill that you need to have. So why do we use it? First of all, we have to hide irrelevant details. Okay? If I want to solve a problem, like I want to, for example, understand the weather. Okay? It's like, okay, I'm going to build a weather model to do that. I'm actually going to worry about the fact that when somebody lights a match, that the smoke that comes up moves the little air this way and that. No, right? I can't do that because if I try to think of it at that level, I'm going to be paralyzed. I will never have a solution for, quote, weather, okay? We have solutions and they're great. They say it's going to rain tomorrow and it doesn't. Maybe it comes the next day and so on, but it's still useful, right? We need to be able to abstract the stuff that matters from the stuff that doesn't, okay? That means we need to be able to identify the salient issues. What exactly is it in this that really makes a difference? Because there's too many things. I need to focus on the things that make a difference, and then I hide the rest using abstraction. Notice that finding those salient issues is analysis, right? It's an analytical skill, right? It's actually not that far off of what you learn in, say, literature, okay? It's just simply, here's the whole thing, now what does it mean? Right? What was the author really trying to get at? What does this problem really involve? Those are the questions that you have to ask, right? And that's analysis, right? By the way, what is really important about this? That depends on what you're doing, right? In some problems, right, if I actually want to make, say, weather predictions, then maybe certain things are important that are not as important if I want to do long-term climate, okay? So that, again, is part of that analytical mindset. It's not just what's important, but what's important for this problem that I'm trying to solve, okay? Now, if you have abstraction, then one of the things you can do is kind of reuse problem descriptions, right? So if you work, for example, in weather, and then later you decide to work in, say, stock market data, okay? It's like there's nothing related from one to the other, right? Actually, you might find that there's a lot of things that are related, and I don't want to scare anybody, okay? But for example, I could say some of the mathematics that goes into weather prediction actually applies to stock market data analysis, things like matrices, vectors, okay? Now, of course, that's abstract mathematics. That's not the point of computer science principles, but it is kind of the point of what I'm trying to get at here, which is that skills transfer. And the reason that skills transfer is because even though we built them in this context, we can then abstract and kind of remove the unnecessary details that are tied to that context and move them over here, right? Where we can say, okay, so I don't actually have temperature, but I do have stock prices on a daily basis. So, the temperature every day, the closing price of Apple in every day, yeah, I can see how I can build something that uses those, right? That's the point. That's abstraction, right? And by the way, it's not just the descriptions, it's the solutions. I may actually write a routine that does something important here and then later realize that it's very important there. And for your students later, when they're in college and they're taking, say, a statistics course, they may learn about like principal component analysis, which actually perfectly transfer from one setting to another. They may have a program that does principal component analysis, and they can now use it in different settings. That's the beauty, right? That's why abstraction is cool. Okay, next big idea of this course is data and information. So what does the College Board want students to know? Well, what the College Board wants them to know is that manipulating data is kind of the thing that we do as computer scientists, right? I hate to put it this way, but that's kind of like an abstract way of talking about computer science. If you look at civil engineers move dirt, right? That's their core competency from one place to another at a very high level, right? Computer scientists don't move dirt, they move data from one place to another. That's what we do at a very high level. And of course, by moving data, we're actually doing stuff like genetic analysis or healthcare or stock analysis or weather, whatever it is, it's just data that goes from one slot to another, okay? That data can be very large. It can be massive, right? So if we can look, for example, at the price of Apple every day. In a year, that's 250 data points. Nothing, right? In 10 years, 2,500 data, nothing, okay? All right, so how about the price of Apple every minute? 60 minutes, 1 hour, 8 hours of trading, 480 values per day. That was actually roughly the equivalent of 2 years worth of daily data, right? Okay, so that's every day. Now let's have 10 years worth of that. That's very large, okay? Forget Apple. Do all of the stocks in the New York Stock Exchange. Okay, that's a lot of data, right? That's one thing that the College Board wants the students to understand, okay? Now, nobody can read that much data, right? If I actually print a file that has the stock price of every stock every minute for the last 10 years, nobody can read it, right? But a computer can go through it and come up with some kind of summary, some kind of aggregated data that can be used for human consumption. For example, you might have graphs, okay, that are easier to capture at once. You might have averages, like not individual stock, but how about the Dow Jones, which is the average of 30 stocks, and so on, right? So that's one of the things that computers are for. They're to transform the data that's out there, my temperature sensor measuring the temperature every second, right? Take that data, transform it in a way that's useful for humans, okay? And if you do that, then that data can actually lead to some new insights, okay? That might help you save energy, for example, right? It'll have real life consequences. So that's part of what the College Board wants you to know. College Board wants you to know about algorithms, right? So what's an algorithm? That's actually the way that we computer scientists do solutions, right? So if you're in algebra, you might have a problem like find x. They give you an equation and you solve it for x and you say the solution is 12, okay? That's the solution to an algebra problem, okay? Actually doing algebra, what they're really doing is they're teaching you a process that you apply to find those solutions. That process is an algorithm, okay? it's step-by-step instructions for doing something, right? That's kind of the way that we define algorithms in computers. We often use the metaphor of a recipe, right? This is how you make paella. Okay, this, and that. Yeah, that feels like an algorithm, okay? An algorithm is a sequence of steps. Do this, do that, do this. Algebra, algorithm. I said that in algebra, you actually learn algorithms to do things. The word actually comes from the very same root. And the root is a mathematician's name. And he was from the East, okay? And I don't know exactly where he lived, but I do know that he comes from the Islam world. And he came up with a lot of these initial algorithms for doing stuff like solving equations that we now teach in algebra. And so he wrote a great book about this, right? And the book starts with the words algebra. And his name actually was algorithm, hence algorithm. So it's very much related. That's really where all this stuff comes from. Okay, fifth big idea, programming, okay? Now, what's a program? A program is just an algorithm, right? That's the solution that we computer scientists come up with, the process for solving problems. But we express that algorithm in a computer language, meaning that instead of writing the algorithm in a way that I can describe it to you, I write it in a way that I can describe it to my laptop, okay? And if I can do that, then my laptop can execute my algorithm and actually do something useful, okay? So that's the kind of a key step in making computer science useful, right, is to actually express those algorithms as in computer programs, okay? Now, there are lots and lots of computer languages. One thing that you learn from AP Computer Science Principles is that there are lots and lots of computer languages, and you can pick the one that you want. A lot of times you can choose the right one for the task. Sometimes your choices are limited, okay? Maybe somebody else made it for you. I want to point out that we have an opportunity here to choose the right programming language for our students, okay? And the choice that I've made by adopting the Beauty and Joy of Computing curriculum, which is what I'm talking about in this class, is Snap. And the reason is that it is an absolutely wonderful blocks-type language, which means you drag and drop blocks to build your program. It makes it very difficult to have a syntax error, which means your students won't struggle with, why doesn't this work? Oh, I'm so sorry, you used a comma instead of a semicolon, right? None of that happens here. So that's great, okay? It's also available on any computer, right, that has a web browser, which means that if your students want to get excited and want to do some of this at home, they can, right? You don't have to teach them how to install the Python environment on their laptop or anything like that. They just go and there it is, right? I can do stuff. They can then show it to their parents, for example. Look what I'm doing, okay? So just for those reasons, I really like this environment. Big idea 6, the internet. Talk about something that the students can already relate to, right? But maybe they haven't thought about what does the internet do, right? And the College Board wants them to really be conscious of the fact that it connects people. It connects computers, connects devices like, the thermostat that's measuring the temperature in the room every second, right? All of those are connected through the internet. That's what it does. Now, we also wanted to learn a little bit about internet technologies, not that much, by the way, just enough to kind of be aware of how they work. So they might know that it involves addressing. Every device connected to the internet has an internet address. Okay, that's one of the things we wanted to know. We wanted to know about routing, so that if I am this computer and I have this particular address, and I want to send a message to that computer over there that has that particular address, how do I get the message over there, right? I may have to give it to this other router that then knows how to go over there, right? So it's just going to take a sequence of steps or hops to get there, right? They wanted to know that. They wanted to know about protocols. They don't want to know any specific protocol, right? But they wanted to know that protocols exist. So why can this computer send email to that one? Because there's an email protocol, okay? That's kind of the level of detail, okay? They also wanted to appreciate cybersecurity. The internet is vulnerable to, hackers, okay? So when you're building stuff on the internet, when you use the internet, you need to be aware of that, right? So that's kind of the big idea of the internet. Our last big idea is global impact, okay? Computation has changed everything. And our students will not appreciate that, okay, because they were born into this, right? So as far as they know, there was never a day that you couldn't just go to Google and say, hey, here's my homework problem, help, okay? They think that that's been like that for the last 100 years. Of course it hasn't, right? Computers have changed everything, right? I mean, my mother lives 1,000 miles away, but you can actually keep in touch with my kids because they text to each other, they FaceTime, they do those things that I mean, I couldn't see my grandmother when I was growing up. So, those are differences that are there. They're positive sometimes, they're negative sometimes, right? It's a balance, and we have to kind of judge that. So in this course, the College Board wants the students to at least start thinking about that. I notice that this will eventually lead to kind of input from the humanities courses, right? What exactly does it mean to be human? Is that changing, right? Is it good for humans to be able to go into a virtual environment and see the Brazilian rainforest, or is it better for them to actually have to go out into a rainforest to experience trees, right? So those are questions that are open. It's really nice to see the students debate those questions, okay? All right, so those are the big ideas. Now let me talk to you a little bit about the performance tasks. These are things that the students will do prior to taking the AP exam, okay? And they replace the free response questions. So these are graded as though they were free response. So the first thing is the explore task. And what the students have to do is go off and learn about some computing innovation that they particularly like, okay? So maybe your student likes to game a lot. Maybe their innovation is a new graphics card that makes gaming go better. Okay, fine, you need something. Maybe some other student is just absolutely fascinated with drones and wants to talk about drones. Maybe it's self-driving cars, maybe it's virtual reality. Doesn't matter. It absolutely doesn't matter. They just need to be interested in something and go off and learn about it, okay? When they learn about it, one of the things that they're going to be forced to do is to analyze kind of the innovation and the impacts that it has in society. By the way, here's a free tip. If the student cannot come up with a positive impact and the negative impact, they need to find another innovation, okay? Because the College Board will actually ask them to discuss those, both. And so if it's like, but this is like computerized sliced bread, it's all good, find something else, right? There's lots of new stuff happening. Once they do all that, they have to build a, quote, computational artifact. Now, what's the College Board really trying to say here? They want the students to be able to use computers, right? This is a computer science principles class. They wanted to use computers to create something cool, right? Maybe that's a flyer, right? That's not very cool. Maybe it's a PowerPoint presentation. It's also not very cool. But that's the kind of stuff they're looking at, okay? So here's what they don't want. I draw something on paper. There's no computer there, right? Then I take a picture of it. Look, it's a picture. That's in a computer, right? No. They want it to be built in the computer. So they actually want if you're going to scribble, you better get a pad and actually scribble on that, okay? So that's what they want. They just want you to use a computer to build something and then use that to describe some innovation that you've learned about and that you're excited about, okay? The create performance task is the only way in this class that your students will actually convince the College Board that they were able to program something at some point, okay? So what they have to do is think about some program that they want to build. It's not a given task. It's not implement this. It's something that they choose. Sometimes teachers complain about that. It's like, please give us a hint, okay? In reality, okay, and I'm one of the people that grades these things in the summer. We don't care, okay? We're not going to give you extra points for doing something that we think is really interesting, okay? Just do something that you like. And when I say you, I mean your students, right? Hopefully something that will excite them so that they can go through and build something cool, okay? It needs to be, they need to build it, right? So they actually need to get it working at some point. And they need to reflect on the process of writing that code. So for example, one of the questions will be something like, think about a difficulty that you faced when you were doing this program. How did you solve it, right? That's the type of questions that they have to answer. All right, so this is an AP course, and as you know, AP courses a lot of times have curriculums that are associated with them that make it easier for you to offer the course. So I will be talking about the BGC curriculum. BGC stands for Beauty and Joy of Computing, and this was actually one of the 5 original pilots for AP Computer Science Principle. Since the pilots, there have been a lot more curricula that have come out there. This is actually one of the original ones, and it was developed at Berkeley, and when they started, they actually offered it at Berkeley kind of as a rough alternative to their Computer Science 101 course. And after a few iterations, they realized, what are we doing? This is so much better than the Computer Science 101 course. We're going to get rid of that class and just offer this course. Right now, it is the most popular course at Berkeley, okay? About 60% of the students in that class are young women. the BGC curriculum completely prepares students for the AP CS Principles exam, okay? So it has everything you need. It's got 8 units, and each unit has content kind of on both technical stuff, like how do we process a list, okay? That's something that you gotta learn as a computer person, right? And it also has societal impacts inside that little lesson. So I might tell you about, well, these are the kinds of things that, say, the government might store in a list. Is that a good thing? Is that a bad thing, right? So for example, right here I have 2 examples that come from different units in the curriculum. At the bottom, you can see a technical kind of challenge that the students are given, which is, here is a list. It has contact information, so it's like the contacts app on their phone. And this is the things that we want to store, and then we may want to write some programs such as, find me the phone number of this person, right? That's the kind of things that they can hopefully relate to, okay? Now, above that, you see a beautiful, handsome face there. That is Edward Snowden, okay, whom you may have heard of. He is either an American hero or a traitor, perhaps both, who knows, okay? That's what we're discussing, right? Societal impacts. So one of the reasons that he's so famous is because he went out and said, hey guys, the NSA has all this information on you, whether you know it or not. And I think you ought to be concerned. And he leaked that information out to the press, and he's been hiding out since then because the NSA does not like to have his secrets shared. Okay, so whatever you think of him, he definitely changed the conversation about security, about privacy in this country. So he's a nice, controversial person that you can have a great discussion with your students about what is the proper role for government, for companies, in the face of all this technology, right? And don't be scared about this. When I started teaching AP Computer Science Principles, I thought to myself, yeah, sure, I can talk about Snowden, but my students won't know about Snowden. It'll be like, you know, they don't have the emotional reaction that I do because I was there when it was happening, right? Every day something is going on. So as we're taping this, Facebook has been revealed to be, well, they leaked all sorts of information about, you know, billions of people to companies and governments and so on. And my God, everybody's upset all of a sudden, right? So we don't have to talk about Snowden. We can talk about Zuckerberg, okay? Those opportunities will present themselves. We don't have to do any work. We just have to go to, you know, news.google.com and see the top item and go, oh my God, this is perfect for my CS Principles class, okay? Here's another benefit. It is completely free. It will not cost your school anything to adopt this curriculum, okay? There's no books to buy. There's nothing to bring, to print, to give to the students. It's all online. We just direct them to that and help them through that, okay? Completely free. The computer equipment you already have, right? All you need is a computer with a browser that can actually get to the curriculum. And like I said, we're using the Snap programming language, which is accessible through a browser. That's how you get at it, okay? Last benefit of adopting this curriculum, you may be thinking, I'm going to teach an AP class. That means I got to do an AP audit. You may have heard nightmare stories about AP audits that last years, okay? Yeah, sure, because if you're going to teach AP calculus, how do I know that you're really teaching calculus, right? Well, that might be fair for calculus, but for this class, we have these things that are very broad that we want students to learn. We're not even saying they need to learn Java. They can learn Java, Python, Snap, all sorts of different things. So we can't quite dictate the curriculum as much, right? I mean, from the College Board's perspective. So they're saying lots of things are possible. If you say, you know what, I love the BGC curriculum, that's the curriculum I want to use, you simply say that in the audit course website and you are approved. Okay, you can now teach AP Computer Science Principles. All right, so that's great. The paperwork is really, really easy. All right, so what is this course about, right? What am I doing? BGC is already out there. So you can actually get training on the Beauty and Joy of Computing curriculum. It's available on the internet, and the folks at BGC actually collaborated with the education department in New York, and they built this 4-course sequence in edX, which is a great online platform. You can just go there, sign up, and say, I'm interested in these courses, and boom, what you will get is basically the lectures that students at UC Berkeley get for Computer Science 101. Okay, it's the same instructor, and he sits there, and he will tell you all these things. By the way, he is a fantastic guy. He is one of the leaders of the Computer Science Principles community, and he's very dynamic. He's fantastic. You will love his lectures, okay? So he can teach you all of the technical content, right? So I don't have to do that. I'm not going to teach you how to program because, my God, there are so many resources already to do that. I'd just be repeating what's already available by some great folks like Dan Garcia from edX, okay, or I should say from Berkeley, but through the edX platform, right? So what I really want to do, okay, is supplement that, okay? So I will supplement what you can get in the edX course and the Beauty and Joy of Computing website. Those will teach you the content. They teach you what you need to know technically to be able to do things, right? I want to help you learn how that content is put together. So I want to be working on kind of at a meta level that kind of shows how those things reinforce each other. Why? This way you can teach it more effectively to your students, okay? For example, that this is being taught now because this is going to be coming up and they're related in this subtle way, okay? I will also help you with the logistics of APCS principles. I've taught this course at Wyoming high schools. So, I've gone through the AP course audit. I've gone through getting the students to do an explore and a create task. I've taught them how to program. I've led the discussions about, Snowden and all that kind of stuff. So I've learned some things, and I want to share those with you, as opposed to, here's how you write a for loop, okay? I let Mr. Garcia or Dr. Garcia teach you that, okay, from edX. All right, so that's what this course is about. That's what we're going to do. Can't wait to get started.